Hello. This first video is mainly to put paid to Gary's silly claim that in the clay experiments done by Emilie du Chatelet and Willem Gravesande, Gary claims that clay is a poor measurement of energy because it gives advantage to speed, to velocity.
And you don't understand the concept that maybe a substance like clay would have a huge bias to fast things.
We understand the concept, but the problem is the concept turns out to be untrue.
The faster they move through the clay, the less they stick to it.
No, that turns out to be untrue. Did you test it? No, you didn't. I did.
The less friction they have with it.
No, this is just complete made-up nonsense. You've not tested it. It's untrue.
The less they
Come on, spit it out, man.
the less they deform it. The less they do all kinds of things.
What in the name of God are you talking about? The less they do all kind of things. What other kind of things do they do other than go through the clay? Are they knitting jumpers? The less they knit jumpers, the less they brew beer, the less they... What other things do objects do when they pass through a material?
The less they do all kinds of things.
The less they, I don't know, read a book. That's something you should have done, Gary.
The less they do all kinds of things.
What other things can they possibly do?
The faster you go through the clay.
This is just pure bull. Pure nonsense.
And you don't understand that concept.
Do you understand the concept that when you come up with an idea, it might be wrong, and so you should test it? You haven't done that. This experiment you're going to see now puts paid to that completely, because what you actually witness is this 4 times mass, which Gary himself would concede is exactly 4 times the energy of that, because it's 4 times the mass. But you witness that making a dent in the clay more than that makes from 4 times the height. So how can clay possibly be given that an advantage? So this 2.3 kilogram weight dropped from just over a foot, 350 millimeters. That displaces at least 16 milliliters of the clay, and this displaces 11 when dropped from 4 times the height. When we drop this from 350 millimeters, this displaces about 3 milliliters. So when we drop this from 4 times the height, it displaces about 4 times the amount of clay. It displaces 11 milliliters of clay, measured using milk from a syringe. Without being silly about it, without being pedantic, we can conclusively say that this really is showing that at twice the velocity, it has 4 times as much energy. So Gary is completely and utterly wrong when he complains that clay gives an advantage to smaller, faster objects. No, it gives advantage, if anything, to slower, heavier objects. And when you think about it, that's logical, because just resting this on the clay, not dropping it at all, just resting it there gently makes a decent dent in the clay. No velocity needed. So if anything, clay is giving advantage to the heavier, slower object, okay? Putting paid to Gary's utter nonsense. So anyway, this video is just to, first of all, establish that clay is a decent measure of energy. Other experiments you will see shortly with a similar title to this one will be the actual experiment itself, done in various ways with various clays at various temperatures. Thank you for watching, I appreciate it. Oh, and if anyone else wants to do the experiment, please do. There's no one doing it on the internet, and it's quite a shame, really, isn't it? We've looked hard and long to find an example of someone doing it. I couldn't find a copy of anyone doing it. So dropping the 574 gram from 1.4 meters again. That's actually that mark, just the top, it's the top of that tape. 3, 2, 1. Okay, let's get that out. I'll try another one from a bit further along. Oh, that was a failure. Oh, forget it. Let's just move on to the one that I really want. The Gary one. This is the one I'm really bothered about doing. So there's the 350 mark. Try again. This I want to get in a clear area as possible, really. That's what we want. That's what we want. A straightforward drop. That'd better be right. In retrospect, I think a little bit of extra clay got stuck to that because when I twisted it to get it out, it looked like there's a bit more clay on it than usual. A bit like this example from another case where I was doing it in very soft clay and it displaced quite a lot more clay than the 574 gram ball from 4 times higher. And only really had that issue perhaps with very soft clay when it was as soft as butter. But it certainly didn't give advantage to speed, it only gave advantage to mass. This displaced 16 milliliters and the other one displaced 11 milliliters. So I think a little bit of extra clay got stuck to the surface of that, accounting for the extra few milliliters there. It's just something to think about though. See, we're learning as we go. Right, that's all I wanted, just one decent drop, so that one there and that one there. Okay, them two. Them other ones are probably not worth bothering with. Okay, switch off. And we had 2 balls. So this one, 574 grams, I dropped that from 1.4 meters and it landed there. Do you remember it landed kind of like that way up, didn't it? That's what that little mark is there, that landed sideways. And then after that I dropped this 4 times that weight, 2.3 kilograms. I dropped that from a quarter of that height, so it goes half the velocity. So I dropped this from a quarter of the height, 350 millimeters, and I managed to get a direct hit at last, and it made that, okay? It stood up, didn't it? You saw that yourself. So the idea is I use a syringe, fill it with milk so you can see how many milliliters each one holds. So you can get an idea of whether Gary's claim is true or not, that he says clay gives an advantage to speed. Now this is obviously 4 times the energy of that if it was dropped from the same height. When it's dropped from the same height, I've already shown elsewhere, it makes a dent, something like, it made a dent something like that. Obviously that's artificial, so I'll just put an extra to do that. But it made a hole, something like that, that holds 3 milliliters, okay? When I dropped that from 350 millimeters. But this, I've yet to determine how deep that is, how many milliliters milk this will hold. But typically the example so far have proved it holds 4 times as much, indicating that clay is actually a good measure of this being 4 times the energy, because it's 4 times the mass. Perhaps I should show the scales as well. I've already done that elsewhere, but anyway, it should be 2,300. It's 2 grams less. And there we go, 574. Let's measure how much milk these will hold. So I'll load my syringe up to hold 10 milliliters, and I see how much this will hold. And previously I know it held at least 10 milliliters. A tad more actually. That's 10, so I've loaded up to 10 again. See how much more I can get in before it starts overflowing. I think we're just at the point of possibly overflowing, and we're on 9. So yes, so that's an extra, that's 11, so that's holding 11 milliliters. Okay, let me write that down. So that's holding 11 milliliters. Now let's have a look at, I'm using milk because it's easy to see milk. Okay, so again I've loaded it up to 10 milliliters. Okay, can the camera see that? Okay, now see how much this one holds. So this one we know is 4 times the energy of what that one. That's 10 milliliters so far. So again, I've loaded the syringe up with another 10 milliliters. Again, 10 milliliters, hopefully you can see. Yes, 10 milliliters. Carry on. Hope the camera's picking this up. Those cameras. Till we get to the point where it's kind of on the verge of overflowing. That's where we want it. There we go. So I've just gone past a little bit there. Okay, went a bit too far, so I'll knock a bit off. So that was, it's on 3 now, isn't it? You can see it's on 3 now, so that's 17 milliliters in fact then. call it 16.5 because I've gone a little tad over. So 16.5 millilitres. Okay, 16. So 11 millilitres, 16, or 16.5 millilitres. Yeah, so knock off a millilitre because. So, in other words, clay doesn't give an advantage to speed. If anything, it's giving an advantage to mass. When you think about it, it stands to sense, doesn't it? Because even if we have zero velocity, let's see what happens if we have zero velocity. And I place this here. This is with zero velocity. I just place it there. I just hold it there. I'm not dropping it or anything. Holding it there. Okay. Now I'll lift it off. And hey presto, there's a mark there. Don't show you. Even with zero velocity, so you can't say that's velocity squared. You can't blame that on velocity. You can only blame that on mass, can't you?